why I'm teaching this today.
Hey guys.
Thanks, man.
Well, for those that didn't show up today, what's up?
Oh, can we get extra credit?
I'm not gonna give you extra credit. I'm gonna tell you guys are gonna be ahead of the game. So today we're gonna work on Traverse calculations or a Traverse example. Okay. So I brought with me today the instrument that we're gonna be using for the labs coming up. As you can see, this is what we call the Automaton GTS 35. Okay. You can see it goes 360 motion. The scope of it goes all the way around. Okay. We have the eyesight back through here where this is focused on the crosshairs, the smaller knob. We have the bigger knob out here that's our focus or crosshairs, and this is the focus on the gray part. As you're spinning it and getting close to the top and bottom here, I don't know if you can really see these little modules down here below. That kind of gets you in the realm close to your target. And then here, because you're going to be so tunnel vision when you're looking through it, you're not going to really be able to see everything. And then this helps you get close, line up. There's a little hollow or a white triangle that you can use to get you there really close. And then you can use the eyepiece to get you focused in on your target. All right. Once you're locked onto your target, or you want to get really locked onto that target, as you notice, if you just give it a push, swivel is very easy. So what you do is we have these locking mechanisms, this insider locking mechanism here, and this one for the vertical. This is for your horizontal. So if you turn it righty-tighty, it can't really move there. And let's say you get locked on, but you're close, but you're not right on the target. This outer knob here does that fine adjustment for you, just kind of like the automatic level. You guys got close and you just kind of turned it easy and just got it there for you. All right. On the side here, we have a packable battery. Okay, those stay on charging in the equipment room. Goes on like that. Let's see. When I say, so we're looking at these field notes and you're looking at these measurements and you're trying to figure out what it means. All right. What we have here is when you're taking one measurement, if you have these two little nodules, especially on the scope of this one, these two on the top, I like they are. This is we call a direct measurement or direct mode. If you flip it 180, you see that they're on the bottom now. That's a reverse. Okay, so you take that would be a reverse shot. So as you can see here by these notes that they have laid out, they sat on on point number 1. They backsighted azimuth mark here, right? And they took a direct for D, and then they took an R in reverse. Okay, so that's what that means. All right. So again, this gives you the information that you need for what we call a horizontal circle. Okay, and that's the exterior or interior angle, be it whatever you're measuring. So like, let's say this example, we're backsighting that prism up there in that corner, right? We set that to 0. So again, we can set this instrument, we can give it 0, just give it arbitrary numbers, right? Especially we're just doing a small traverse around like this area. And we could set whatever we want to, whatever target to 0 via the total station once we turn it on. All right, so it turns on like that. We can log on to it, say that's our 0 up there, right? And our next target is up here at this prism. And again, we always turn in the clockwise or turn right. So it would turn as such this way, right? So that would be measuring the what angle? Outer. The exterior, right? The outer, right? It would be measuring the exterior angle there, right? So we would have to do the math to compute the interior, right? So again, on this plate, depending on what you're wanting to do, you have what we call the V or the zenith, right? On that locate there, and the HR, the horizontal circle, as it's sitting here on right here, right? So again, these notes are provided under the week 5 module, under the modules week 5, and it's called example traverse field notes. Okay, that's what we're following today, and that's what we're going to be doing for the entire traverse example. So we look real quick at the homework. We have these steps that we're going to be doing. So this is what we're going to be running through with all the notes. So we're going to do reduced field notes. We got an A and B section on that. We're going to calculate the misclosure of the angular misclosure. We have an A and B step section. We have adjust the error, reduce the slope distance. For this example, I'm going to try to find a different example, but because we have as we go down the notes, it's 90 and 270 for the example that we have. The slope distance would equal the horizontal distance. If it's just a straight 90, right? But if there is a slope distance, I'll show you the formula to figure out the horizontal distance, because what we are looking for in our measurements, these distances measure the slope distance, okay? These distances here on this example. So then we're going to compute the azimuth of the traverse lines, okay? We're going to calculate the unadjusted coordinates, and then we calculate the area of the traverse with 4 parts to it. Then we're going to apply the compass rule with a departure and latitude, and then we're going to calculate the adjusted coordinates. All right. So again, this is a huge, long list of things. So this will carry on over till next week. This is why I want to kind of hold off till we had a big chunk of time to go through this entire traverse adjustment part, because this is like the meat and potatoes of plane surveying, right? Running a traverse and running a adjustment to it. So for lab on Tuesday, we're going to do it. It's going to be a 2-parter lab. The first part on Monday morning, we'll go through doing what's just calibrating the instrument, closing the horizon, making sure that the instrument closes in a 360 fashion. And then the second part will be the following week, and we're going to run a small traverse around campus, right? So with your group, right?
On Monday or Monday?
Sorry, the following Tuesday. So we got Tuesday, right? We got next lab that's going to be closing the horizon, just calibrating this instrument, and then the following Tuesday after that, we'll do it the second part of this lab 5 traverse around the campus. All right. So again, let's get started with some field notes. So again, first thing we're going to do is we're going to work on reducing field notes, right? So we go back to our notes. We take a look at what we have for the first part. What we have is I'm just going to write this kind of as I can. So again, we look at this HI. Oh, this isn't right. Okay, this where it says HI, that is your height of instrument, and that is taking. Did I leave that? Oh, right down there. That is taking the height of instrument, whatever point you are on physically. So let's say there's a physical point, like you set a hub with a nail down below. You take a tape measure, and you physically measure it with a pocket tape, and then using this mark here, this guide, that is the bisection of your scope right there. You take your HI measurement to that line, and you record it in tenths of feet. So for this one, it is 0.515. Right, so it would be 5.15. For their notes, they use just 50. The HR is the height of rod. So those prisms that you see sitting there, it'd be from the tip of the bottom of that pole all the way to the top of the center of that prism that you see there. Right, it'd be right at the center. If you look at those orange squares around them, they have like a little triangle. Right, that triangle is pointing center to that prism. So you can go to those little triangles on the outside of those prisms as well. All right. So that's what they mean by HI and HR. All right. So again, our step 1 will be to reduce field notes with this first type of notes. So let me just write it out real quick for you. Grab my notes too. So our instrument, so first thing to do is reduce field notes, right? That's step 1. All right. So again, we're gonna go hit A first, and it's gonna be the average measured angles So from essentially we're set at point 1 here, right? We're set at point 1. Let me just make a little sketch here. So we're at point 1 here. Our total station is here. And we are, again, backsighting this azimuth mark. And then we are going and we're hitting point 2. Right? That's the first thing we're doing. And again, if we're set up here, right, our angle is going to look something like that, right? Our exterior angle or the measured angle, the notes that you are collecting, right here. These ones, this horizontal circle. So again, let's say view the notes. You took your measurement and you set that first backside, you set that to 0. So in the total station, you have that option. You can set the instrument to 0 for your first line of shot, your first line. You set everything to 0, right? And then you turned, right? Took that measurement, you turned it to the right, you calculated, and you got 186, 23, 22, 23, right? So that's the first part there, okay? So then the way that we reduce that in the field notes, we go average angle is equal to, again, this is just one big long equation of our, and I'm going to write it as they have it here on the notes, like these dashes, okay? That's going to represent our degrees, minutes, and seconds, right? I'm going to write it this the way they have it in the notes, just so they can reflect that. It's going to be in parentheses, that's your 186. 186, 22, again, in parentheses, right? And that's going to be plus, so again, this is the direct right here. And then we're going to have the reverse on the side. That's going to be that 6, 22, 26. And again, the way we reverse it is we're sitting here at that prism. We flip it 180, right? We flip the scope 180, and we go back to that target there. And that's how we get that reverse number, that 622, 26, right? That's how we get that reverse. And then again, the 180, 0 minutes, 1 second. Again, this is going to be all over 2. Okay. Again, that 180, 0 seconds, 1 minute is again, you take your measurement there at 2, and now you turn back to your azimuth to get that last reading there. Your reverse reading at azimuth there. Does that make sense? Does that all? Does that make sense? That part? The way we were measuring, right? Again, I'm going to flip it back in direct. So I'm taking my 0, I'm setting this instrument to 0 on that prism there. That's my azimuth mark. I take it, I set 0, I take my measurement. I got my measurement. Now I'm going to go to number 2, right? Because I'm on 1.1. I'm going to go to number 2 over there, take my reading, and I got that 186, 22, 23. Okay. Now, again, now I got to go 2 shots in reverse. So again, I flip it 180, go back to that number 2, get that measurement reading. I got 622, 26 for the reading. And then I got to get one more shot back on my azimuth, right where I started from originally, right? I turn it back to the azimuth.
So when you're in the inverse, are you doing the interior angle once you go from left to right, or is it still going to be technically the outer angle?
It's going to give you the outer angle,
Okay.
Because it's still measuring too.
Okay.
So again, and you go back, and it's going to give you your reading in the reverse mode. Okay, back at your azimuth, and again, you get 180, 0 seconds, 0 minutes, 1 second. All right. So there's that. So that average angle comes out to be 186 degrees, 22 minutes, 25 seconds. And again, this is, I need to put this part down to clarify. This is from your azimuth mark to point number 2, right? That's just that piece, right? So, are we done? Done getting all the average angles?
Where did the 6 degrees, 22 minutes come from?
Again, you flip your instrument in reverse mode, and that's 180 from itself, and that's how you get that measurement. You want to see it physically?
I think I'm just getting mixed up because this is like 90 degrees.
Well, no, well, yeah, that's fine. Well, come see this physically then.
Okay.
I'm gonna turn it on for you, right? I'm gonna set this to 0 real quick. If you guys want to see this experiment in the making, again, it's not all the way technically correct, right? Because I don't have 186 figured out right off the top of my head. Okay, get close. I'll lock this guy in. I'm in reverse. So sorry. Let me go back to direct. Lock that guy in. It's in. So again, here is where I set to 0. So I set to 0, I'm gonna hit yes. So that's 0 right there. Right? HR, so that's 0. Okay? So now what I do is I go swing to the right, and I go collect there. And again, you can see it on this plate, on this side of the plate too. Yeah, so let's just, for the sake of this example, let's just say that's 186, right? So again, I'm on 0 right there, right? Now, if I want to go in reverse mode, all I got to do is just unloosen the Y one. I go here, now I can do this, loosen the X, go back to it, show me what that, and then you can tell me here in a second what that reading is.
109.
Right, 180 from itself.
Yeah. Okay.
Understand? Make sense?
A little.
Ramon?
Yeah.
Okay, so again, that's the reverse and direct mode right there, right? That's what that means when we're doing the reverse, and that's what we also call a turning an angle, okay? So in order to get that, that's what we call turning an angle, well, or wrapping your angle, right? So we got 0.1 there. What would be the next step? Anybody? We go to 2, right? We go to 2.
As with the point 2.
What's that?
As with the point 2.
No. So now, yeah, sorry, yes. So because you're at 1, right? Your total station is at 1. So these angles are from your azimuth to your point Q. So physically, you're here, right? You took your 0, and you came back, and you got the reading from between your azimuth mark and your point Q. So then we get that done, we get that set. Now what's the next step? We gotta physically move, okay? Now we gotta physically move. We're gonna be on point number 2, okay? So what's gonna be our backside? Point 1, right? What would be our foresight? 23, right? Yeah. So again, we come up, and let's just say, because again, we are on point 3. This is from 1 to 3. And our average angle is going to equal what we're given there. Okay. And then for this argument or this example, they just set their direct to 0, right? And then they went and wrapped their angle. Again, we got 0 degrees, 0 minutes, 0 seconds. Are 263, 58, 32, right? It's going to be plus R 83, 58. Zero minutes, 1 second. right? Again, all over 2. So then this average angle becomes 263, 58 minutes, 33 seconds. We good? Move on. All right.
Where'd you get 263 degrees?
So again, this is from the field notes. If you look over here, right? I need to be zoomed in. So again, we're at point number 2. All right, these guys did their measurement, they set it to 0. So again, they were sitting here on this point, and they went 0 here, and then they went, wrapped their angle, and they got to point 3, and they ended up getting 263, 58, 32. Sitting directly on point 2, backside in 1, foresight in 3. Good?
No, that helps much.
Okay, so now, moving on to physically picking it up, right? Sitting on 3, now we backside 2. We backside 2 and we foresight 4, right? So again, this piece here is 2 and 4. Yeah. And again, the average angle here. Gonna be just these values right here. Right? On point 3. So station at point 3, backside 2. The information for the height of instrument, the information for our backside height of rod. Right? Maybe right there, I guess. Or 108, 47. Again, all over 2. So the average angle there, 288, 47, 03. So again, these are all the exterior angles, right? We're calculating the exterior, or taking the average and getting the average of the exterior angles, right? So on a smaller version or smaller scale, right? We're getting these numbers here, right? For now, doing the exterior angles, right? All right, so again, we got 2 more legs to do, right? So we go down here, by the notes, we got to physically set up on 4, right? Get the backside to 3, and then foresight to 1. And then we got to pick up again and get back on 1, backside 4 this time, rather than the azimuth mark, right? And then foresight back to 2, right? To get that, which is exterior angle. So we go again, 3 to 4. And our average angle being our values there on the field notes. It's going to be exactly as it's there. over 2. So now our average angle for that, from sitting physically right at our point at 3, or sorry, 4, 4, 3, 4, 4. That should be, yeah, so physically sitting at 4, backsighting 1, and going to 3. The exterior angle there, the average, 248, 10, 48. Next one I'm going to do is down here below. And I'm going to go again, physically set up on 1, backside 4, yep, backside 4, and go foresight to 2 again. Well, this one is, we go back up to the notes. So now you're back at 1, but instead of backsighting what we did the azimuth mark, we're backsighting number 4. No, you were at 4, you backsighted 3, and then you went to 1. That's this. That's this one here. That's this one in red. Now we went back to 1, but rather than backsighting our azimuth mark, we had the backside 4, and then foresight 2. And this is how we geometrically and mathematically close on a traverse, right? This is how we make it mathematically and geometrically close.
And you couldn't do that the other way. But the foresight, backside, switching.
Well, that'd be turning your angles to the left. Yeah, which we don't do because that's not from normal. So again, the exterior for that one is going to be 279, 03. Any questions there? All right, so that was part A of step 1, right? We can kind of grasp that concept. We're just getting the exterior, the average of the exterior angles. Good? Okay. So let's put this in a table format, right? So we can kind of see it with so the next part is going to be calculate the interior angles on our step 1. Right? So I'm going to put this in a table for you guys so we can kind of get this looked at in an overall picture. Okay. So again, just to keep the organization, we're still going to be step 1. And again, reduce field notes. Okay. And we got now task number B, or task B, and that's going to be calculate interior angles. Okay. So again, just a note, or just to make a note for you guys for later. In the example, or this example, Angle's right. Our exterior. So we must subtract 360 from each angle, right? To obtain interior. Again, putting this in a table format. We have our point. Let's say 360 here. We can calculate from 360, subtracted by our exterior. And then we have what it equals the interior. Angle. Okay. Put a line there. So again, we have 0.1 here. And the constant of 360 because we got to subtract 360 from every single exterior angle. And that average angle that we had for that constant on 0.1 was 279, 3 minutes and 30 seconds, or sorry, 40 seconds. 279, 3 minutes, 40 seconds. So the interior, right? The interior portion is going to be 80 degrees, 56 minutes, and 20 seconds. And again, for 0.2, we had 263, that's the exterior, 58, and 33 seconds. Now our interior is 91 degrees, 1 minute, 27 seconds. The exterior of number 3, we had 288, 47, 03. That interior is 71 degrees, 12 minutes, 57 seconds. Again, for the exterior of 4 is 248, 10 minutes, 48 seconds. Interior is 111 degrees, 49 minutes, 12 seconds. Now that we have all our interiors, what would be the next step to do as soon as you get all your interiors? No, you don't have to do better. No, we're not worried about the after part yet. We got all the interior portions of our traverse, right? We turned all our angles, we got it all, we came back on ourselves with all our measurements. What would be another check now?
Add them up,
And
like
see-
360.
Exactly. Make sure we equal to 360, right? So we have to take the summation of the interior angles, right? And for this, we got 359, 59 minutes, 56 seconds. We got close, right? 4 seconds isn't bad, right? Not 360, but we're right there. I mean, it's 100th or so, right? In terms of distance.
Does that mean that it doesn't close mathematically?
I mean, yeah, in the field measurements, right? Or I guess the theoretical, the calculator, it doesn't, right? Mathematical. But in the field, talking this much,
Okay.
right? Talking this much. I mean, I can guarantee you, you can get on that total station right now and try to move it 4 seconds, and it's gonna be, you're gonna sit there and fidget with it for 4 seconds.
So then would we then do the error and then do the adjusted?
Yes,
Okay.
that's what we're gonna do. Yeah. So we got step 1 completed, right? This is step 1. We got step 1. How many steps do you say we have?
5.
9.
Yeah.
We have 9 steps. Again, this is the meat and potatoes of plane surveying, right? Making a traverse work. All right, so on to step 2. We're going to calculate our angular misclosure. Again, let's go back to these steps real quick, right? Calculate interior misclosures. We got A side, right, and we got a B side. So N is we're going to apply our formula, our interior angles. Okay. B is we're going to check geometry or geometrically correct interior angles sum against the measured interior angles. All right. So again, we ended up getting 359, 59, 56. So again, if we apply the formula with A, we have N minus 2 times 180, right? Well, what's N for us?
5.
Number of setups, right? 4, right? 4. I know we had 5 overall, but does that first setup count as part of your traverse?
Cause you just,
That's just your 0. That's right, where you're just coming, where you're orienting your survey from, right? You gotta have you have to come off of a known point, but that's also considered, that's not considered part of your traverse overall, right? So it's 4 points. So N is equal to 4. So then it's just going to be 2 times 180. And that's going to be 360, right? Again, we take that from our measured angles. We get 0 degrees, 0 minutes, 4 seconds, right? So because we are lower, or we don't meet it by 4 seconds on the low side, what would you think would be the appropriate thing to do here, or the next thing to do? Add or subtract?
Add.
And what are we going to add?
You said 1 second to every setup?
You just add a second to every setup, right? So again, that's going to be the part B of this, right?
So you just divided that by 4.
We divided, so right, we got 4 setups, or you got 4 seconds, right? By your 4 setups, 1 second, right? So again, we're going to correct. To your angle. Again, make a nice little table to keep you guys organized. We have the point. And here we have the interior angle. We have the correction of what we were applying. We have our now adjusted angle. Again, we have point 1 here. The interior angle, or the measured interior angle, or the The interior angle here was 80 degrees, 56 seconds, or sorry, 56 minutes, 20 seconds. And again, our correction is plus 1 second, right? Pretty easy to see that it's going to be 80, 56, 21. Right. We got 96. 7. Yeah, again, 1 second. And again, we have 96. 1 minute, 20 seconds.
Where does 96 come?
96. So 96 is from, again, come up here. We got the average exterior angle. You know, 360 minus our average exterior.
I was like, oh, no.
Good job. Good job. Great job. 91. I'm looking at my notes too closely, not following the actual process here.
They're gonna say.
Still.
Yeah, we're still 27. Thank you.
Oh no. Sheesh. I do wonder. Just looking at tree.
Again, we're gonna add that 1 second to 3. Keep checking me. Make sure my notes are following what they need to be. Apparently, I don't do that enough. One of those things where you get tunnel vision when you look at something for so long that you start losing track of the actual numbers and you just look at the process. And then all of a sudden you get fresh eyes and you go, hey, that's not adding up. Oh yeah, you're right. It's not adding up. $13, right? Now, the summation here, the interior could equal 360. You guys had enough? All right, it's 3:45. Let you guys go. So step number 4.
Oh my god.
Step number 4 is calculating the horizontal distances. We're not going to do that for this step, but I will show you the formula when we come back on step 3. Or sorry, step 3. Yeah. Step 3. Step 3.
You were.
I have a list.
That, this is what our second thing.
Wow.
Okay.
Caribbean.
This is in class.
Caribbean.
Where's all?
Bro, I want Dutch bro. Dude, I don't know if I
George, don't do it.
No,
it's not.
It's not, but
Especially
Oh, it's open up?
it's right next to school. It's
I've
fast.
only got
Oh,
one
okay.
in there.
My mom had me at tea this morning. It's Bravado
So
though.
it's like.
Is
Bravado is so good. Ooh, I love it.
Why is each step more? Is each one A, B?
Well, you got yeah.
Oh, you want the anti?
Thanks.
Yeah, I don't want
Everything
it.
good?
Ugh, girl. Better than the wall you decided to throw. You should just leave in the. Oh, I'm never. Dude.
Just in